Okay, right. See, let x1 comma x2 or any two real numbers or any two real number and x1 lesser than x2. Okay, x1 lesser than x2. So what shall we do here, Amma? We can make them to standard form like 3x plus 17. So here multiply first with 3. So 3x1 lesser than 3x2. Then adding 17 on both sides. So 3x1 plus 17 lesser than 3x2 plus 17. Okay. So from the equation 1, let us take the given function as equation 1. From that it can be written as f of x1 is lesser than f of x2. F of x1 is lesser than f of x2. So what shall we conclude finally? Therefore, f of x is increasing or not?
Increasing.
Yeah, strictly increasing we can write. Therefore, f is strictly increasing function.
Can you scroll up a little, sir?
Yeah, okay. Okay, that we know the condition x1 lesser than x2, which implies, okay, which implies f of x1 is lesser than f of x2, which implies f of x1 is lesser than f of x2. Then f of x is, what about f of x? Increasing function on capital R. It's a simple question or 1 marks question, it might be. And next, second question. What about the second one? F of x value is they given as e power 2x. E power 2x, this you can do it. Directly first you can take x1 is lesser than x2 and 2x1 is lesser than 2x2 and e power 2x1 is lesser than e power 2x2. Like that you can take. Okay, this is nothing but f of x1 lesser than f of x2. Like that you have to write. This is second one is homework. Then third one. So what about the third question? Show that the function sin x is increasing. Okay, increasing function in 0 to pi by 4. Already we have seen it is clearly increasing, but how to write the steps? Yeah. Third one is f of x is equal to sin x. F of x is equal to sin x. So when f of x is equal to sin x, so method 1 or method 2 we need to apply here. Yes, method 1 or method 2?
Method 2.
Yeah, it's better to you can apply method 2. Okay. This is the given function. Let us take 1. So we have to write the steps to differentiate equation 1 with respect to x on both sides. So f dash of x is equal to cos x. F dash of x is equal to cos x. So f dash of x is equal to cos x. So what shall we do here? Yeah. At this f dash of x, we have to check. Yeah, you have to write like that. So you have to write since for each, like for each, what is the interval they given? What is the interval they given for each? 0 comma pi by 2. The first subdivision is 0 comma pi by 2. So what about the cos x value? Cos x is clearly greater than 0. Am I audible properly?
Yes, sir.
Yeah. So for each and every value from 0 to pi by 2, cos x is greater than 0. So cos x is nothing but f dash of x. F dash of x is greater than 0. Therefore, according to the method to f dash of derivative is greater than 0. So what about here? Hence f of x is strictly, yeah, increasing. Strictly increasing in 0 to pi by 2. In the same way, okay, since next is second point, second subdivision. Okay, since f of, what shall we write? For each x belongs to pi by 2 to pi. 90 to 90. What about cos x, Amma? Greater than 0 or lesser than 0? Second subdivision I am doing here. Second subdivision B. Okay, so cos x is lesser than 0 because second quadrant cos is negative. It is a second quadrant, in second quadrant cos is negative. So when cos x is negative, then cos x is equal to f dash of x. F dash of x also lesser than 0 for every x belongs to pi by 2 to pi. Pi by 2 to pi. Therefore, or hence, what shall we write? F is strictly decreasing. Decreasing in pi by 2 to pi. Is it clear, students? Have they just check that first derivative value, then it is greater than 0, strictly increasing. Lesser than 0, strictly decreasing. It is greater than or equal to 0, just increasing. Lesser than or equal to 0, decreasing. Then what shall we write in third subdivision? Third subdivision. Okay. From the above one. Okay. So clearly f is increasing in 0 to pi by 2 and decreasing in pi by 2 to pi. So hence it is clear that f of x neither increasing nor decreasing. Like that you have to write. Any doubts, students? Here, third question. Okay, I have taken like given function, I differentiated on both sides. I have checked that f dash of x whether greater than or lesser than 0 in given interval. If it is greater than 0, increasing, lesser than 0, decreasing, like strictly. So increasing as well as decreasing, then we can say that f of x neither increasing nor decreasing. That you have to write. So already they are asking to show it is neither increasing nor decreasing, 0 to pi. So no problem. We will write at the same step. Okay, fourth one is again find the intervals in which the function f of x is given by same 2x square. So we can use the derivatives method 2. F of x is equal to 2x square minus 3x. F of x is equal to 2x square minus 3x. What is f dash of x? 4x minus 3. 4x minus 3, here find the interval in which the function is given by first case is increasing. First case is increasing. Am I right? The first subdivision is increasing. Increasing. Whenever it is increasing, f dash of x we can take as 0. greater than or equal to 0. So what is f dash of x students here? 4x minus 3. Greater than or equal to 0. 4x is greater than or equal to 3. X is greater than or equal to 3 by 4. So nothing but, what is the required interval here, students?
3 by 4 to infinity.
Yeah. So here, yet if you take any real line, actually, here we can write like this. So therefore, the required interval is is 3 by 4 to infinity. That's all. Then what about the second subdivision? B, decreasing. In decreasing, here we are taking greater than or equal to 0. In decreasing, we can take lesser than or equal to. Clear? So f dash of x is lesser than or equal to 0. F dash of x value is 4x minus 3 lesser than or equal to 0. Finally, same, x lesser than or equal to 3 by 4. Nothing but, what is the required interval? Therefore, the required interval is
minus infinity to
exactly. The required interval is minus infinity to 3 by 4 equal. Okay, nothing but what you observe, if you take any real line here, real line, so at x is equal to 3 by 4, so in right hand, right side, clearly it is, here it is increasing. F of x is increasing. And here left side, f of x is decreasing. Left side is f of x is decreasing. Okay, so now the point is 3 by 4 divides the real line into two disjoint interval. Okay, that is what minus infinity to 3 by 4, 3 by 4 to infinite. That's all. This is enough to write. These are the 1 mark or 2 marks questions. Okay. Next, like question numbers 5th, 6th, like more than like this 11th, 12th and all, these are the 3 marks or 5 marks questions. Is it clear, students? Right. Question number 5. Again, same. Here also differentiate. Find f dash of x here. F dash of x, you can take greater than or equal to 0. You'll get some x values. You'll get some interval. In that interval, it is increasing. So f dash of x, take lesser than or equal to 0. You'll get some intervals in which the function is decreasing. That we can do. So let us go for the question number 6. Okay. So you can do the 5th one. So in question number 6, either we can do by making completing square method, or else we'll do directly by method 2. Method 1, method 2. Okay, right? Question number 6, the first one is, so what is the given function, students, here? X square 2x plus 5 minus 5. X square plus 2x minus 5. Okay, ma, what shall we do here? We can make them to like a method 1, method 2. I'm doing here method 2. So method 1 is, you can make them to completing square form. F of x is equal to, it can be written as x square plus 2x plus 1 minus 6. Oh, okay, nothing but yes, here from here to here, it can be written as x plus 1 the whole square. Yesterday I already explained here. Okay, so here method 2 is, f of x is given here. F of x is equal to x square plus 2x minus 5 f dash of x. F dash of x is equal to 2x plus 2. 2x plus 2. The question here, find the interval in which strictly increasing or decreasing. See here, x square coefficient is positive. So every quadratic equation represents a parabola. Parabola, that graph and all you know very well. The parabola is U-shaped. Okay, like it is, like whenever x square coefficient is positive, it will be open upwards. Open upwards. Okay, nothing but what it is increasing. Okay, so right now what shall we do here? Easier we'll take f dash of x is greater than or equal to 0 or lesser than or equal to 0. Students, see what is x square coefficient here? X square coefficient is positive, nothing but it is always increasing. Increase means f dash of x is greater than or equal to 0 or lesser than or equal to 0.
Greater than.
Yeah, greater than or equal to 0. So your f dash of x you can take greater than or equal to 0. Yeah, take f dash of x and find this. Nothing but x belongs to what? -1 to infinity. Okay, -1 to infinity. Just a moment. Yeah. See, students, from this we got x greater than or equal to -1 means -1 to infinity. So in this interval the function is increasing.
Sir,
Yeah.
so they are strictly increasing. Sir.
Oh, they're asking about strictly increasing, no? Okay, you should not take a greater than or equal to. Just take greater than. Very good. Is it clear? In the question they're asking strictly increasing, so that you should take like this. Nothing but here we should take open interval. With help of method 1, see here x plus 1 the whole square always greater than or equal to, yes, greater than or equal to 0. Clear, students? Then x plus 1 the whole square minus 6 greater than or equal to -6. Okay, so this will give that minimum value. Actually minimum value is -6. For what value of x it is -6 at x is equal to, when x is equal to -1. Okay, so you can give -1 to till infinite, it will be positive alone. So otherwise x plus 1 equating to 0, x is equal to -1 will get. But here the question which is belongs to increasing, so that hence f of x is increasing from -1 to infinity. So it's better to you can approach that method 2. Method 2 is easy, you know. The function is given, differentiate that function. When you differentiate that function, you are going to get 2x plus 2, clearly strictly increasing. F dash of x is greater than 0. Strictly decreasing means f dash of x is lesser than 0. Like that we can do. Okay. So what shall we do here? -1 comma infinity, open interval. In that it is strictly increasing. Therefore f is strictly increasing in -1 to infinite. That's all.
Strictly
Yes,
decreasing, right, sir?
we cannot write for this question strictly decreasing. Why? Because I said, you know, it is always increasing function. Increasing function, x square coefficient is what? Positive. X square coefficient is positive, so we are going to get the minimum value. Minimum value is -6 we got. Yeah, minimum value, you know, we got minimum value -6 means maximum value is infinity, nothing but it will start with -6 to infinite like this. So it is increasing. Okay, then second subdivision.
Sir,
Yeah,
sir, if we take values of x is lesser than -1, sir, we will
lesser
get
than
f
minus.
dash of x is negative, no, sir.
If we take x values as
Lesser than -1.
lesser than -1, okay, so what is the output you are going to get?
So f dash of x will be negative, no, sir.
Where here
Yes,
we
sir.
cannot, yeah, we cannot consider that negative value, no, here what we consider here. So if you see that x square coefficient is positive, you know, whenever it is positive you should check just increasing alone, no need to check decreasing. Okay, it is an increasing function, because even if you see here, this can be written as x plus 1 the whole square, it is greater than or equal to 0, and x plus 1 whole square -6 greater than or equal to -6, nothing but what do you observe, this is clearly equal to f of x. F of x is greater than or equal to -6. F of x nothing but the value, the range. Okay, so the minimum value is 6, so by giving a different x value it will be increased, the least value alone -6.
Okay, sir.
So if it is like instead of like greater than or equal to -6, if we get lesser than or equal to -6, you know, that time it is decreasing like that. Okay, let us see now next question also there. So what is the next question? We have 10 minus 6x minus 2x square. Let's see here. Second option is yeah.
Sir, in the previous question, how to check whether it is strictly increasing or just increasing, sir?
See, the thing is, yeah, here strictly they asking, you know. So
Okay, sir.
already I have written a completing square form, like yeah, here x plus 1 the whole square minus 6 I have written. See, you can take any value like either positive value or negative value, it is square will be there, no, whole square is there. Whole square nothing but for different values of x, it may be positive, x may be negative, we'll get the different value. For any value of x, easier we get the two equal values. Substitute any value of x, any two values, is it equal? No. Take any
Yes, sir.
two values, it should be not equal, so that it is strictly increasing alone.
Yeah, thank you.
Strictly, right. So every quadratic, a parabola, if you take the parabola, either it is increasing or decreasing like that. It is increasing or else it is decreasing. But is there any parabola graph like this? Like someone like this? It is not constant, no, for any two values. Either completely to U shape, either completely decreasing, okay, from here to here, or it is increasing, continuously increasing. But it's the graph is not like this. At certain point it will be equal, not like that. So every quadratic equation is a parabola. Every parabola always strictly increasing or strictly decreasing. Remember that. Next question. So I have taken your,
Sir,
yeah,
sir, for the previous question in the answer they gave for strictly decreasing also, sir.
strictly decreasing also they given.
Yes,
Every
sir.
quadratic is okay, decreasing as well as increasing. Just I'll see, I'll check it once. Okay, strictly increasing. It is increasing alone, no? All of you check once. They given
So we
decreasing
have
also.
decreasing also, sir.
Oh, right. Okay. See, the thing is, right. As you said, it is a parabola, no? So it is U-shaped. It is decreasing as well as increasing. But Right, here -1 is there, no? The real line, it can be divided into two parts. Take here, x is equal to, we got it -1, -1. So more than -1, f of x is, right side is increasing. Like previous question, I explained, no? Left side f of x is decreasing. So it is strictly decreasing. Right. Because every parabola equation you can take decreasing, increasing. Even downside also increasing, decreasing. So we can write like this. So f is strictly decreasing in the interval like -∞ to -1 open. And the next, thus f is strictly increasing. Yes, increasing in the interval
-1 to infinity.
-1 to infinity. You should not take it is closed bracket, just open bracket. Right, Amma? At -1, it is a constant. More than -1, for every value of x, it will be increased. But at exactly -1, the value becomes 0. Like that. Here we got x greater than 1, increasing, lesser than 1, lesser than -1, decreasing. Okay, second question. First, I want to write -x square, -x square, or -2x square, -2x square, -6x plus 10. Okay, with help of derivative test, what is f dash of x? F dash of x is equal to -4x minus, here, students, here it is the x square coefficient is a negative. Based on the x square coefficient, see this condition we can use for finding minimum and maximum. Okay, for finding minimum and maximum, x square coefficient is positive, we are going to get minimum value, we don't get maximum value. Maximum value till tends to infinite, like this. We are going to get minimum value. It will tends to maximum value is infinite. We get. But when x square coefficient is negative, this is very useful for finding maximum and minimum. So here x square coefficient is negative, so it will be open downwards. Open downwards means it has maximum value. What is the minimum value? Minimum value means it will tends to -infinity. Minimum value -infinity, so that we cannot consider -infinity. So when x square coefficient is negative, we are going to get a maximum value. X square coefficient is positive, we'll get a minimum value. In that case, it is very useful to you. But to check increasing and decreasing, just simply differentiate. -4x, -6. Now what shall we do here after differentiating? When I f dash of x is equating to 0, that is -4x -6 equal to 0. What about x value only? -3/2. So the x is equal to -3/2 can divide the real line into two parts. It is two part. X is equal to -3/2. So what about right side, Amma? Is there f of x is increasing or decreasing? Right side. What about left side? Yes. Decreasing or increasing? Increasing. Decreasing. What about here? F of x is increasing. Okay, so here, therefore, so in interval, if you take that in interval like x greater than or else lesser than, okay, x greater than -3/2. So what is f dash of x value, Amma? F dash of x is 6 minus 4x is lesser than 0. Yeah, take any value, if it is more than -3/2, f dash of x value is always lesser than 0. Lesser than 0 or greater than 0? Yes, students? Lesser than 0 or greater than 0? That is my question. Lesser than 0. Okay, so therefore f is strictly increasing or decreasing? Decreasing. In minus 3 by 2 to infinity. So same, strictly increasing. So minus infinity to minus 3 by 2. That's all. So you have to write the steps, the proper steps. It is not a difficult. Okay, differentiate and you can draw the real line. So if you get two different points, you can identify both the points on the real line. Okay, like plus minus plus. Curvy wave method we can use to check increasing or decreasing. Okay, that is easy. Like any other question, students, you want to give any other question like C or E? Which one will do? Choose remaining question. You can do D question. D also it is clearly quadratic, but whereas C and E, these are cubic and sixth degree polynomial.
E, sir.
E,
Yes.
yeah, E. So the question is x plus 1 whole cube, x minus 3 whole cube. So the question is f of x is equal to x plus 1 whole cube, x minus 3 whole cube. So find f dash of x with help of UV rule. Let us take this is u, this is v. All of you find f dash of x, twin. F dash of x you can find, and equating to 0 you are going to get x values. You can find those x value on the real line. X plus 1 whole cube into the derivative is 3 times of x minus 3 the whole square plus x minus 3 the whole square into x plus 1 whole cube is 3 times of x plus 1 the whole square. So what is the common here? 3 is common. X plus 1 the whole square, x minus 3 the whole square. So what is the remaining value? Here it is x plus 1 plus here x minus 3. So 3 times of x plus 1 the whole square, x minus 3 the whole square. Okay, 2x minus 2. This is f dash of x. So this f dash of x equating to 0. So what are the x values we are going to get here? F dash of x is equal to 0 means this is also equal to 0. X plus 1 is equal to 0. X minus 3 is equal to 0. 2x minus 2 is equal to 0. So x is equal to minus 1. X is equal to 3. And x
1 minute, can you scroll up, sir?
Yeah. So apply UV rule. Now here we can use curvy wave method. Not required, we'll write the steps along. Clear, Amma?
Thank you, sir.
Yeah. Yeah, you can identify all these 3 points on the real line.
Can you scroll up one step, sir?
Yeah.
Okay, sir.
So all the points are correct here. What are the points we got it here? Yes.
X equal to minus 1, 3 and 1.
Yeah. Minus 1, 1, here 3. So where it is increasing, where it is decreasing, Amma, can you tell me, can we say directly? See f dash of x alone, when it is greater than 0, when it is lesser than 0, that we need to check. So finally it will be till x plus 1 the whole square, it is always positive, and x minus 3 whole square, it is also always positive, but 2x minus 2 alone. Based on this, the value will, the sign will be changed, either greater than or lesser than. Here this is always greater than 0, this is always greater than or equal 0, but this is depending on the x values, either it is greater than or lesser than. Okay. Okay, just I'm giving one task here. So already I found the points, just in next class, you have to write the corresponding interval where it is increasing, where it is decreasing. In which interval it is strictly increasing, strictly decreasing, that you have to write. Because it's already 12:40. Can you do?